Hey guys, welcome back to another video. In this video, we'll be learning about the first derivative test, and the first derivative test states that given c is a critical number of f, if f prime changes sign from positive to negative at x equals c, then there is a relative maximum at c f of c. If f prime changes sign from negative to positive at x equals c, then there is a relative minimum at c of f of c. So take a moment or two to copy this down in your notes, and when you're done, come back to the video and we'll do some example problems. Okay, so I'm assuming that you copied this in your notes. So let's go to our first example problem. So for our first example problem here, we are asked to find the relative extrema of f of x is equal to negative x cubed plus 3x squared. In order to do this, we first have to find the derivative of f of x. So we have to find f prime of x. F prime of x is equal to, and this is equal to negative 3x squared plus 6x. So now we have to find the critical numbers. In order to do that, we set f prime of x equal to 0. So negative 3, and I'll just simplify it right here to make it easy. It's minus 2. And from this, we get that our critical numbers are x is equal to 0 and 2. So let's draw that in a box. Critical numbers. And now for the next step of the problem, we have to plot these points on a number line. So 0 and 2, like so. So now we have to find the sign change of certain intervals. So for example, from negative infinity to 0, we can figure out the sign of it by plugging in a number between negative infinity and 0, such as negative 1, for example. So f prime of negative 1 is equal to negative 3 negative 1 squared plus 6 times negative 1. And this is equal to, well, negative 1 squared is positive 1, so this is still negative 3. Negative 3 plus negative 6 is equal to negative 9. So we get that the sign from negative infinity to 0 is negative. So we can write a negative like that. And also, if you didn't know, this is the graph of f prime right here. So next we have to find the sign from 0 to positive 2. So in order to do that, we have to take a number between 0 and 2. So a number between 0 and 2 is 1. So we can find the derivative of 1. So f prime of 1 is equal to, we plug it in. And if we plug it in, we get it is equal to positive 3. So positive 3 is a positive number. So we can write a positive sign like though. And from 2 to infinity, we can use the number 3. So let's do that. F prime of 3 is equal to negative 3 squared plus 6 comma 3. And if we plug this all in, we get that is equal to negative 9. So that means from 2 to infinity, it is a negative sign. So we can signify it like that. And now we have to find the relative extrema, which is also known as the relative minimum or maximum. And for this, we can use the first derivative test we learned earlier up here. And the way to use this is we find when f prime changes sign from positive to negative, then it is a relative max. And if it changes from negative to positive, then it is a relative minimum. So let's go back to our number line here. At point 0, the graph changes from negative to positive, which means that there would be a relative minimum at x equals 0. So let's write that in. Relative minimum at, and then don't forget, we have to actually use the point here. So we get 0, comma, and then we have to plug in to f of x. And in this case, f of 0 is just, well, it's just 0. So there's a relative minimum at point 0, 0. Now what about the relative maximum if there is one? Well, the relative maximum is when f prime changes sign from positive to negative. And in this case, at point 2, the signs change from positive to negative, which means that there's a relative maximum at point 2, comma, and now we have to plug 2 into here. So if we get f of 2, and let's just do it to the side right here, f of 2 is equal to, and if we just solve it out, plus 3, 2 squared, like so. And note, this is f of 2 from this function right here, not f prime of 2. This would be equal to negative 8 plus 12, and this is equal to 4. So this is 2, 4, like so. So from this, we learned that there's a relative minimum at the origin, which is 0, 0, and a relative maximum at 2, 4. Take a moment or two to copy this down in your notes, and when you're done, unpause the video, and we'll move right on to the next example problem. So for our next example problem here, we're asked to find the relative extrema of f of x is equal to 1/4 of x to the 4th minus 2x squared to the 2nd. So, and to do this, we have to follow the steps we did last time. We first have to find the derivative of this. So, f prime of x is equal to x cubed minus 4x. Now we have to find the critical numbers, and in order to do that, we have to set f prime of x equal to 0. So I'll just simplify this. X minus 4, and this is x squared. And we get that x is equal to 0 and positive or negative 2, like so. Now for our next step, we have to make a number line, and we have to plot the points on it. 0, 2, negative 2. And also, just as a side note, if you're reviewing for your calculus exam or something, or like your AP test, I suggest you check out the playlist that I made for calculus. It has videos for you covering all topics that will be on the AP test. So I highly suggest that you check it out. It will be linked in the description. So, and let's get back into this. So, what we have to do now is find the sign change. And in order to find the sign change, we have to graph something between negative infinity to negative 2. So let's do that. So a number between negative infinity and negative 2 is negative 3. So f prime of negative 3 is equal to, and this would just be equal to negative 15 if you plugged it in here, because negative 3 times 9 minus 4 is 5, so that's negative 15. But the important part here is not the value, it's the negative. So we know that this is now negative. And now from negative 2 to 0, we can plug in a number such as negative 1 for say. And if we plugged in negative 1, we would get, well, this is negative 1 right here. So negative 1 times 1 minus 4, which is negative 3. Well, that would just be positive 3. So we get that this is a positive. And now what about 0 to 2? Well, we can plug in a number from 0 to 2, and one such number is f prime of 1. And if we plug this in, we get that it is equal to negative 3. So this is becoming a negative right here. And now for the final set right here, we can do f prime of 3, because 3 is between 2 to positive infinity. So f prime of 3 is equal to, and if we plug this in, we get that is equal to 27. And for this one, I'm using the top equation because the top equation is a bit easier. So this is equal to 27 minus 12, and 27 minus 12 is positive 15. and this will become a positive right here. So what this all means is that we can find the relative minimum and maximum using the first derivative test. So let's first find the relative minimum. Now, if you didn't remember, the relative minimum is when it goes positive. Oh wait, my bad. My bad. It goes positive. Wait, no, negative to positive. I don't know what I'm saying today, but it goes negative to positive right here. So from negative to positive, we can check. -2 is negative to positive, so there's a relative minimum at -2. And +2 is also negative to positive right here. So if we plug this back into f of x, we can get that the relative minimums are at -2, comma, and it'd be f of -2. And in this case, f of -2 would actually be -4. So let's write that in. And now what about at 2? Well, it'd be 2 comma, and then the relative minimum states that the y values are the lowest on a certain interval. So if this is the relative minimum and the y value is -4, then this must be the same y value, so also -4. And also, if you were unsure, you could have just plugged in this as f of 2 and found that it was equal to -4 as well. And now what about the relative maximum? So from the relative maximum, it is positive to negative. And we see from here that 0 is positive to negative. So this is 0, comma, and if we plug in f of 0 into this equation for f of x, we get that 0. So overall, there was a relative minimum at -2, comma, -4, and 2, comma, -4, and there's a relative maximum at 0, comma, 0. Take a moment or two to copy these down in your notes, and when you're done, come back to the video. So if you copy this down to your notes, this is our final example right here. Find the relative extrema of f of x is equal to x cubed. Take a moment or two to try this on your own, and when you're done, come back to the video. So if you took a moment to try this on your own, you might have found something weird possibly, but I'll demonstrate it anyways. So f prime of x is equal to, because that's the first step to find the derivative, f prime of x is equal to 3x squared. Now we have to find the critical numbers. So 0 is equal to 3x squared. In this case, x is just equal to 0. This is our critical number right here. Now we can draw a number line and list 0 as a point. And now we can find 1 and -1, because we're looking from 0 to infinity and -infinity to 0. Well, if we plug in 1 for here, we get that f prime of 1 is equal to 3. So this is a positive number, so we can write positive right here. Now what about f prime of -1? Well, f prime of -1 is still equal to 3. So we can write a positive number right here. Now, what does this all mean? Well, you see, since the sign did not change at all, it just stayed from positive to positive, we see that there is no relative extrema. And we can write this by doing relative extrema, and then we say none. And then if they ask us to justify, we can write none because no sign change, like so. Well, I hope this video helped you with your test, or if you did not understand the concept, I hope that helped you with that. And if you need more help for calculus, I will have a calculus playlist linked in the description as always. And until then, see you guys in the next video.